All right, this is a video that's going to cover lesson 10.6. We did cover this lesson in class, but maybe some of you missed some things that were covered in class, or if you were absent, this is definitely where you want to look to get this information. So we're going to try and go through this kind of quickly. First of all, I want to teach you about a new vocab term, and that's called a secant. You'll remember from lesson 10.5 that a tangent is any line that intersects a circle at exactly one place. And a secant is a line that intersects a circle at exactly 2 points. That's your new definition here. So lines J and K are both secants because they intersect circle C at 2 distinct points each. So that brings us to the main idea for this lesson, and that is that we have intersecting lines with circles, and if I put two lines that intersect a circle in some way, either a secant or a tangent, and those lines intersect each other, there's three possibilities. Okay, two lines could intersect a circle in the interior of a circle, where the vertex of the angles is on the inside of the circle. Okay, if you look down further, two lines could intersect a circle at one point. In that case, one of the lines will have to be a tangent. Okay, and that's in that case the two lines intersect at a point on the circle. That means the vertex of the angles are on the circle. So we've talked about inside the circle and now on the circle. And then you'll notice in the last part of the notes that we have two lines intersecting outside of the circle. And we'll talk about all those cases, but they create a relationship between the angles and the what we call intercepted arcs. And so that's what this first part's going to be about. Okay, so first, if I have two lines that intersect creating angles with a vertex inside the circle, any one of those angles is equal to half of the sum of the arcs that it goes with. So like this, if I am talking about angle 1 is intercepted by arc AB, but then its vertical angle, which would be congruent to angle 1, is intercepted by arc DC. So angle 1 is half the sum of those two arcs, AB and CD. But if we change over to talking about angle 2 is intercepted by arc BC, and angle 2's vertical angle is intercepted by arc AD. So angle 2 is equal to half the sum of those two arcs, DA and BC. Now, you also need to pay attention to the fact that the measures of angles 1 and 2 would add up to 180 degrees. Said the wrong thing. Angle 1 plus angle 2's measures add up to 180. So let's say I knew these two arcs, but I was looking for angle 1. I would use the formula to find angle 2 first, and then subtract it from 180 to find the measure of angle 1. Okay? So let's try some of these examples. Now, we won't go through every single one of these examples, but I will show you the answers that we got in class. But I want to give you just an idea of how to do these. Okay? So in example 1, first we're going to find the value of x for this example. Okay, we are given that x is this angle created by intersecting lines in the interior of the circle. And we have an intercepted arc of 88 degrees, and the vertical angle has an intercepted arc of 76 degrees. That means that the angle measure is half the sum of these two arcs. So the angle measure, x, is equal to 1/2 the sum of 88 and 76. Okay? 88 plus 76, and keep the 1/2, we haven't used that yet. 88 plus 76 is 164, and half of 164 is 82. That means x is a value of 82 degrees. 82 is half the sum of 88 and 76. It's the average. That's a way you can think of it. This angle is the average of these two arc measures. Okay? Example B I want to do also with you, because what you'll notice is the x that we're looking for is not connected to the two arcs that you're given. X would be the average of these arcs, AB and DC, but we don't have those. So what we're going to have to do this time is recognize that x plus this angle measure here would add up to 180. Okay, they're a linear pair. They add up to 180. So if I can find this angle measure right there, then I just take it away from 180. Okay, x is going to equal 180 minus, let's call this another variable. Let's pick the letter y. Okay, so x is going to equal 180 minus whatever y is. So the first thing we're going to do is find the value of y. Y is the average of these two angle measures, or arc measures, I'm sorry. The angle y is equal to 1/2 the sum of 72 and 92. Okay, so 72 plus 92 equals 164. Again, it's just coincidence that it's the same measure we had there. And half of that is still 82. That's not our answer though. We want to find x. So I'm going to do 180 minus 82. So x is 98 degrees. Okay? Alright, if you want to pause the video now and try and do part C on your own, I want you to pay attention to this. You're looking for x, and they give you all 4 of these different arcs, so you really just have to pick out the 2 that are going to be connected to this angle x. Okay, so you're going to use 90 and 160. Pause the video to try and work this one out like we worked out the first example, and then get an answer, and then I'll show you what we ended up with. Alright, if you need more time, pause, but this is what you should get. You should get x is 125 degrees there. Alright, now as we move on to example 1D, you'll notice that there's a difference. Here, we are given the angle measure, but we're missing one of the arcs, x. Okay? So I'm going to use these 2 arcs still in this angle measure, but I don't set my equation up as x equals this time. I set my equation up still as the angle equals half the sum of the arcs. So x is going to go in for one of these 2 arcs in our equation here. But the angle measure we know. So we start with 60 equals 1/2 the sum of these arcs, x plus 25. And now we just have to work backwards to solve for x. As we work backwards, some of you are thinking that you can probably distribute first. Normally I would, but that's a 1/2, and I really don't want to deal with any fractional or decimal values. So I'm actually going to cancel out the 1/2 first. You'll remember that the last thing we did on all these steps is divide by 2, which is the same as multiplying by 1/2. So the first thing we're going to undo is that 1/2, and we're going to multiply by 2 on both sides. Because on this side of the equal sign, multiplying by 2 cancels out that fraction. So we now have 120 equals x plus 25. And all we have to do is subtract 25 from both sides, and we get that the value of x is 95 degrees, and that's an arc measure, so that arc measures 95 degrees. Okay, you can set this one up in very much the same way. You're given the angle measure, we're looking for an arc measure, so your equation is going to look a lot like that. Pause the video to give yourself time to do that, and then when you're ready, push play. If you haven't given yourself enough time and pause, then again, keep it paused. Otherwise, this is what we should get. This arc measure should be 102 degrees. Alright, so you can now see that we're ready for this next theorem, and that's whenever we have an angle created by 2 intersecting lines where the vertex of the angle is on the circle. There really is only one arc to look at for each of the 2 angles. Instead of 2 different arcs, we just have the one. And so we're going back to what we learned in lesson 10.4, that anytime the vertex of an angle is on the circle, the angle is half of the arc. So, angle 2 in this diagram goes with arc BCA. So this angle would be half of that arc. And angle 1 on the other side goes with arc BA, the minor arc. So it's half of that minor arc. Now, this is an easy way to remember this. Angles 1 and 2 form a linear pair, so they would add up to 180 degrees. Arcs AB and BCA, the major and minor arc, add up to 360. So still, the angles, plural, are half of the arcs, plural. 180 is half of 360. So that's another way you can remember that the angle is half the arc. So we're going to try these examples, remembering each time that the angle is half of the arc, but I want to show you a couple things to be careful. In example 2a, we are asked to find the measure of arc BCD. BCD is this arc, which does not go with this angle. However, if you remember that these two arcs, the major and minor, add up to 360, if I find this arc first, the bigger arc, which does go with the angle measuring 108 degrees, I can subtract it from 360 and find this arc, which is what I want for my answer. So here's how we're going to do this. To get this arc, we are going to do 2 times 108, because the angle, 108, is half of the arc. So that's 216 degrees. This arc would be 360 minus 216, which gives us 144 degrees. Okay? We're going to do problem on C very much like that, but on part B it's a whole lot easier than that, because if you look at the arcs we're using arc PTS, and we are to find angle QPS. So the angle is half of the arc. So in this case, all we have to do is do half of 250, which is 125. Okay? Again, pause the video if you would like to try part C. Otherwise, this is what you should get. We do get 125 degrees again. It's just, in this case, we're given the minor arc of 110 instead of being given the major arc of 250. So these are very much the same problem, just with different labels. Alright, so we've talked about lines that intersect inside the circle. Now we just finished talking about lines that intersect on the circle. Now we're going to look at when that vertex of the intersecting lines is outside of the circle. And we have 3 different cases we could look at, either 2 secants, or a secant and a tangent, or 2 tangents. In either case, there are 2 arcs that we will be using. Okay, the bigger arc and the smaller arc created by the intersecting lines. But when we have 2 tangents like this, the bigger arc is a major arc and the smaller is a minor, and they would add up to 360. Okay, so let's try an example. Alright, let's find the value of x here using this principle, which needs to be talked about still. Anytime that the vertex of an angle is outside of the circle, when the 2 lines intersect the circle, we're still going to take half of the 2 arcs, but instead of adding the 2 arcs, we're going to subtract. And we'll always subtract bigger minus smaller. That way we get a positive angle measure. We don't use negative angle measures. So in this case, the value of x is equal to 1/2 the difference of the arcs, not sum. We want to subtract when the angle is outside. So we do 110 minus 40. 110 minus 40 is 70. And half of 70 is 35 degrees. Okay? But on part B, we do this a little bit differently. Okay? On part B, they give you the angle measure, so you don't set it up as x equals, we set it up as 62 equals, still do the 1/2, but now we are given this 141 degree arc, but we are looking, this is a typo by the way, we should just be looking for the measure of arc BC. So let's call that x. So we want to take the difference of these 2 numbers, and so we will do 141 minus x. Now to solve this for x, we still want to multiply both sides by 2 to cancel out the 1/2. 2 times 62 is 124. So 124 equals 141 minus x. The way I would choose to solve for x now is to actually subtract 141 from both sides. Subtract 141. And so we get negative 17 equals negative or minus x. So if negative x equals negative 17, positive x equals positive 17. Okay? Alright, I'm going to show you the answer for part C. We don't have enough time in the video to work it out completely. So I'm going to show what that answer is, and we'll talk more about it in class if you were absent. When we have situation like this, one arc can be labeled as a variable, n, and to find that we would do 360 minus n. So when I take the differences, I do it that way, and we get 220 as our answer for that arc.